Okay, so let me explain
Wait,
first.
where even is the problem?
Today, complex numbers, they're like a new group of numbers. So think about when you were little, you started counting, right? And these are your counting numbers, your natural numbers, 1, 2, 3, and so on. And then you got a little bit older and realized there's a zero value, right? No candy means nothing, right? You're not going to have any, zero amount of candy. You started processing that when you're about 1 or 2, thinking, oh, there's a such thing as zero, as nothing. You start getting that. And then about 3rd, 4th grade, teachers start introducing that there's numbers in between there, right? And you think, oh, there's like a 1/2 between 0 and 1. And maybe like more in 5th grade, you start to understand like 2.2 is between 2 and 3 and 2.7, and you start recognizing decimals, or 2 and 3/4 mixed numbers. You start getting that 4th and 5th grade. And then come middle school, oh, and there's negatives too, right? Negative, you get those too in about 3rd grade. And then about middle school, your teachers start showing you numbers like this, right? Irrational numbers, square root of 2, pi, square root of 7, and so on, right? You get that new set of numbers called irrational numbers. So there is one more group of numbers you haven't seen before, and those are called complex numbers, and they are imaginary numbers. They look like this, the 2i, 4 plus 7i. Those are called imaginary numbers, complex numbers. Okay? They're used for a lot in engineering when you need to represent two things with one number. So like example, if I said this piece of paper, what is the length of this piece of paper? Well, there's two lengths here. So if you had to put one number into a formula to recognize the length of this paper, you use a complex number, something like 11 plus 8.5i, right? Or a lot of times in automotive, there's one thing going, but there's a whole bunch of movements, right? There's two heights. There's the holders going up and down, and then also your piston that's going up and down. So how do you represent that with one number? And they use complex numbers. That's what they're used a lot in engineering. Okay. The reason we study them is because we have one more scenario, right? We did quadratics like this, where we factored and said, oh, x plus 2x plus 2, and I only have one answer, -2, right, for this equals 0. What that means is when I have a parabola, it's only crossing at -2. That's it. And then we got more quadratics like the ones today, and I'm just going to do ones that factor for simplicity, right? No, that's not a good example. 3x, that'll work. And I can factor. And I get 2 roots. I get x is -2, x is -1, and what that looks like is this, where I'm going to cross it in 2 points. Okay? So there is a third scenario. And the easy one to show you on that would be something like x squared plus 5. X squared plus 5 means I moved 5 units up. So if I go 5 units up, here's my parabola. Well, I'm not crossing the x-axis. Therefore, there's no real roots. No real roots, but there are 2 imaginary roots. Okay? So if you look over here, look what happens if I set this equal to 0. I would subtract 5 and have x squared equals -5, and then square root. And this is where mathematicians got stuck because they're like, you can't square root a negative number. Well, you must be able to, because what about all of these quadratics? That's what came about the new set of numbers. If you're square rooting a negative number, this negative becomes an I. You take the negative out with an I, meaning that it then becomes imaginary, right? It becomes on the complex plane. So I have these 2 roots, plus or minus I root 5. And the reason you take out that negative is because now I have this, and 5 and 1 doesn't break down, but if it did, you could break it down. You could simplify. Before you were stuck and wouldn't be able to simplify, but now you can because now you can take out the I. This becomes a new set of numbers.
Okay. I square root of 4.
Right, so whenever you see, the first thing you're going to do, whenever you get a negative underneath the square root, you're going to take out the I. So see how I have a negative? The first thing I'm going to do is take out an I. Now I can simplify because before I couldn't square root of -4, but now taking out the I, what's the square root of 4? 2. So I have plus or minus 2I. Same with this one, I have a negative, so I take out an I. Can I reduce square root of 7? No, so it just stays plus or minus I root 7. 15, take out the I. Can I reduce 15? No, it's just 5 and 3. There's no 2 of anything. So it just stays plus or minus I root 15. Negative 81, I can take out the I. Now I can square root 81. Square root of 81 is 9. So I get plus or minus 9I. Negative 50, whoops, take out the I. But 50 breaks down 5 and 10. 10 is 5 and 2. There's 2 5s, I can take one out. So I'd have plus or minus 5I root 2, because the 2 stays underneath.
You always put the I after?
Yes. It kind of goes in this order. Your coefficient, then the I, and then the radical. That's kind of like the proper order for it. I always goes right in front of the radical. So you can do operations with complex numbers, just to show you a couple of them. Adding and subtracting and multiplying. I's work a lot like X's. They're just another variable, basically. So when I'm adding two complex numbers together, you have a real part, and then you have an imaginary part. So when you're adding, you add the real parts together, and then you add the imaginary parts together. So adding two complex numbers together equals a complex number.
It would be like 3I squared.
That's when you're if you multiply I times I, that's I squared, but I'm adding. Okay. So like this one, here's my real parts. Here's my imaginary parts. Add the real parts, add the imaginary parts. So I get 1 minus 7i. Subtraction, you got to be careful because subtraction, you're subtracting both terms. So when I'm subtracting a term, I like to carry that through first so I don't make mistakes, because I'm really subtracting the 2 and I'm subtracting the negative I, which becomes positive I. Right? So do the subtraction to both first, and then you can say, okay, 12 minus 2 is 10. 5i plus I is 6i. Right? Distribute that subtraction through first so you don't make that mistake. So again, I would distribute the negative to both. So minus 1 minus 3i. So then I look, okay, here's my real parts. So negative 7. Here's my imaginary parts. Negative 10i. So you can also multiply with i's. So this is what you need to know when you multiply. We know that I equals the square root of negative 1. That's what we know, right? Because an I equals the negative underneath the radical. So if I want I squared, right, that's going to be the square root of negative 1 squared. Well, what happens with a squared and a square root? They cancel each other out. So if I square a square root, they cancel out, and I get negative 1. So the important thing you need to know when multiplying is I squared is negative 1. So how do we use that? Well, let's look at a multiplying one. This, I'm multiplying two binomials, so it's a FOIL. So you take negative 6 times 1. You take negative 6 times 3i, so negative 18i. You take negative 5i times 1. You take negative 5i times 3i, which is going to be negative 15i squared. I times I is I squared, just like x times x is x squared.
You don't need a parentheses.
Nope. Once you multiply everything, the parentheses go away. Okay. Now, what do we know about I squared? This I squared is what? A negative 1. So I'm not subtracting 15, I'm really adding a 15 because negative 15 times negative 1 is positive. Okay, so that becomes plus 15. Now I have my two real parts, so 9, my two imaginary parts, minus 20, what? 3i. We'll do another one of those. Negative 6 plus 15. Okay, so FOIL. 8 times 2, 16. 8 times 7i, 56i. And then you do this one, I times 2, 2i. I times 7i is going to be 7i squared. But what do we know about I squared? It's really negative 1. So instead of adding 7, I'm really subtracting 7. Now I can combine my real parts. 16 minus 7 is 9. Combine my imaginary parts, plus 58i. When you're squaring, you just square each one. So I square the negative 6, which is 36. And then I square the I, which is I squared. But what do I know about I squared? It's negative 1, so really this is negative 36. And if you have a binomial squared, you should hopefully know that this means 9 plus 4i, 9 plus 4i. Right? Anything squared means it happens twice. And then I would just FOIL again. 9 times 9 is 81. 9 times 4i, 36i. 4 times 9 is 36i. 4i times 4i is 16i squared. Which is really going to be negative 16, right? So 81 minus 16, 65, and then 36i plus 36i would be 72i. So the only difference when you're solving these from what you did before is, spoiler alert, you're going to get a negative underneath the square root, right, on all of these. Right? I purposely picked these quadratics so you get a negative, so they're all going to have i's. Okay, so that should help you out. If you don't get an I, you did something wrong. So basic, there's two of them. These will be quadratic formula. These just basic solving to practice. So solve for b. So I would subtract 1 on both sides. Divide by 4. So I get this. B squared equals negative 1/4. I need to get rid of the squared, so I square root. Okay. Now look, I'm square rooting a negative 1/4. So I need to take out an I. And then I can look at my square root, and I'm square rooting a 1, and I'm square rooting a 4. Those should be familiar to me and think, oh, they're perfect squares. The square root of 1 is 1. The square root of 4 is 2. So I would have plus or minus 1/2 I. Okay, I usually goes behind. So do another one of those. And then we'll do a couple of quadratics. So add 100. Divide by -9. And 109 should look like good numbers to you, because they're both perfect squares, right? So I square root both sides. I have a negative underneath the square root, so I need to take out an I. And then square root the 100, which is 10. Square root the 9, which is 3. So plus or minus 10/3 I would be my answer. So you're going to need quadratic formula. They're not going to be factorable, obviously, because they're going to be complex numbers. So A is 1, B is 2, C is 3. So quadratic formula, negative B plus or minus the square root of B squared minus 4 times A times C all over 2 times A. Right? Just A for A, B for B, C for C. Order of operations, which is very important. Negative 2 plus or minus 2 squared is 4. Negative 4 times 1 times 3 is negative 12. Right? Multiply first, then subtract. So I get negative 2 plus or minus the square root of negative 8 over 2. Okay. So all of my operations are done, but just like before, you need to simplify that. So what you should notice first is that there's a negative underneath the radical. So I have to first take out an I. So negative 2 plus or minus I root 8. Now that 8 I can break down. 4 and 2, 2 and 2. So 2 2's I can take one out. So negative 2 plus or minus 2I root 2. Because there's a 2 left, so it stays underneath. Okay. Now I should notice that, oh, I have a lot of 2's here. I can reduce all of those. So it would be negative 1 plus or minus I root 2. That would be my 2 answers. Could you check these with the graphing calculator? No, because they're I's. Your graphing calculator is a real plane. Your graphing calculator is a Y and an X. For these roots to show up, you would need a complex plane, and your graphing calculator doesn't have that. But what a complex plane looks like, would be an I and an X. And then it would show your roots. Okay? But these don't have imaginary complex plane. But that's where they would be, where you would see them. Let's try one when A is not 1. Like the next one over. This one. So again, quadratic formula, x equals negative b, so negative 1, plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So what's that? Negative 1 plus or minus, we had an order of operations. So 1 squared is 1. Negative 4 times negative 3 is 12. 12 times negative 3 would be a negative 36 over negative 6. Then subtract, that's your last step, to subtract. So negative 35. So I should recognize right here, now that I'm reducing it, oh, there's a negative underneath. I better pull out a 9. So 1 plus or minus I root 35. What happened to my negative, right? There we go. Does 35 reduce now? No. 7 and 5, there's not 2 of anything. So really that's my answer. I'm done there. If you wanted to go one step farther and really make it look professional, you would take this double negative and make it positive. But if you left it like this on the test, I wouldn't count that wrong, right? But this would be like what you'd see in the back of the book. They would take those negatives out.